Hello friends. So in the previous session we have started with our series of lectures on the parallel operation of AC generators. I have told you that this is a very important concept in synchronous generators, and in the previous session we have seen what are the advantages of using a parallel operation of generators. So some of the advantages that we spoke about was that if you are having a big load, so it is much more economical and practical that you use multiple generators of smaller load capacities to supply the load rather than building one huge generator, which is impractical and not economical. Another thing was that the reliability of the system is quite high. That is, even if one of the generator fails, there are other generators which can supply the load. The third condition was that in cases where you want a shutdown maintenance or a preventive maintenance, if you remove one of the generators, you can do all the preventive and the shutdown maintenance, whatever is required, and the other generators will supply the load. And then you can you can bring in the generator which has been maintained, and then you can take the other generator. So that is also possible. And the last point was that if only one generator of a big capacity is load and the load demand is not that much, we told that that was a very inefficient process. And specifically in diesel generators, I told you that it can cause a process called wet slacking. Okay, so that is what we have seen in the previous session. So today we are going to see the conditions required for paralleling of generators. Okay, now remember one thing, I want to set some things straight initially itself. These are the conditions required for paralleling. Okay, so the parallel operation has not happened. So we have not closed the switch for parallel operation. These are the conditions which have to be maintained before paralleling. Okay, and only after these conditions have been met, you use a procedure, okay, proper procedure to do the synchronization or parallel operation of the alternator. So let me bring that straight. Many of them confuse these two topics, that is the condition after synchronization and the conditions required for synchronization. So there is a slight difference between these two. So with all that said and done, let us start with what are the conditions which are required for paralleling. Okay, there are basically 4 conditions which are required for paralleling. So I will just put them down here. So the first condition is that the RMS line voltages, for example, you are having, in this case, you have shown 2 generators, right? So let us take the 2 case itself. So the RMS line voltages of both the generators have to be same. Okay, have to be same. Okay, we will go through why these are important in a minute. And the second condition is that the two generators must have the same phase sequence. Okay, same phase sequence. I think you should be knowing what is a phase sequence, what is a phase, and what is a phase angle, and all those things. These are all prerequisites to this course on AC machines. Okay, these are all basic AC fundamentals. The third thing is that the phase angles, okay, of the two, you are having 3 phases here, right? So 2 phases. The phase angles, say for 2 of the A phases, or B or C, okay, B or C should be equal. Now in case you are connecting it to a bus bar, then it should be in relative to the bus bar. Okay, and the fourth point is that this is one important point here. Okay, the frequency of the oncoming generator. So the oncoming generator is usually the generator which is going to be parallel. So in this case, if you see that G1 is already supplying the load. Okay, so G2 is the generator which you will bring into the system by pressing this paralleling switch. Okay, so you can clearly see it from the diagram here. So the frequency of the oncoming generator, so the G2 is the oncoming generator. Frequency of the oncoming generator must be slightly, okay, very slightly higher than the system, higher than the frequency of the running system. Okay, of the running system. Okay, so these are the conditions that are required for paralleling. Okay, these are not the conditions after paralleling. These are the conditions which are required for paralleling, that is before closing this switch. At this point of time, I would like you to refer 2 videos. One is by BTC Instruments. So just go into YouTube, type parallel operation of generators space BTC Instruments. Okay, they are having a very good practical demonstration of how this paralleling operation occurs. Another video which you can see is that just type in parallel operation of generators space marine engineering or ships, something like that. So these people actually do a parallel operation in a local environment, not only to the bus bar, they do it in a local environment, and they tell all the practical aspects and practical difficulties what parallel operation can do. They change various parameters and show you how all these things are happening. So rather than watching all these theoretical videos that you can read from the book itself, go for something practical so that you get a good understanding of the system. So these two videos, try to watch them. Now let us take the first case here. The first case is the RMS line voltage of both the generators have to be same. Now what happens if the RMS line voltage is not same? Okay, so if RMS line voltage is not same, and say for example you close the switch, okay, for example the RMS value is not same and you do a bad thing and you close the switch here like this, okay, that means the value of the voltage between VA dash B dash and the value between VAB is not the same. So what will happen? So for example this value E2, okay, is less than this value E1, okay, E2 is less than E1. So what will happen? Just like DC generators, if the voltages are not same, you will have a circulating current which flows like this, right? So it will go like this and it will go like this. So this is a circulating current that will be present within the generators, between the two generators, and this is not a good thing. This can harm the generator in a very bad way. Okay, so if the voltage difference is too high, in fact the motors can get damaged. But usually these kinds of damages does not occur, because what happens is that there are protective mechanisms to prevent all these things. But these are but if you have such protective mechanisms and every time you are trying to sync the generator, the protective mechanisms are tripping off the generator, then you will not be able to do the parallel operation. So even though the generators might not get damaged because of the protective circuits, you will not be able to parallel the generators if the voltages are not exactly the same. Another thing is that the phase of the two systems should be equal. Okay, while paralleling the system, the phase of A and A dash, B and B dash, and C dash should be exactly same, and only then you should do the paralleling. This point I will explain very clearly when I am going through the 3 dark lamp method. Okay, at this point if I try to explain, it will take a lot of time. So remember that these 2 points are very important. Okay, and the second point here is that the 2 generators must have the same phase sequence. Okay, for example, now let us assume that they are having different phase sequences. So for example, this generator G1 has a phase sequence A, B, C. Okay, and say the generator G2 has a phase sequence, say A, C and B. Okay, so now here between the A dash, B dash, C dash, yeah. So this is the rotation of the phasor. So in the phases A, in the A phase of both the generators, nothing will happen because they are both in phase and they are having the same voltages. Okay, but you see in the next point here, at one point C dash is there and the other point B dash is there. Therefore, so what happened was that we actually connected the generator like this. Okay, we actually connected the generator like this. Therefore, between the C phase of this generator and B phase of this generator, enormous amount of current will flow because they are 120 degree out of shift, right? This is C dash and this is C dash here. They are 120 degree shifted out. So between A phase will not have any problem, but B dash B and C dash C will have huge currents line running through them, and that also can damage the machine. Okay, again there will be protection circuit. So if you want to just change the phase sequence, you just swap 2 phases and the phase sequence will be matched. So let me just change it back to the original condition. Here let me just mark it to the original things. So this was B dash and this is C dash, and they are having the same phase sequence. Now the fourth point is that the frequency of the oncoming generator should be slightly greater than the frequency of the running system. Now if you have the same frequency and you put the paralleling switch, what happens is that, no, before that let me just tell you what happens if the frequency is very highly different. The frequency is very different of these two generators. What happens is that you sync the generator, all the other conditions are maintained. For example, this are maintained. What happens is because of this difference in frequency, huge transients will happen within the generator. Because in parallel operation of generators, once they are synced, one generator, if it is running slow, the other generator which is in the system will try to make the other generator run fast. So this conditions we will discuss later. So it is like a mechanical coupling which is happening. It is of course not mechanical, it is an electrical coupling which tries to make the slower generator run faster. So all these transients will happen, and if frequency difference is very high, it can damage the generator. Okay. So to avoid these high transients, you should try to make the frequency almost same. But the frequency should not be exactly the same also. The frequency should be slightly higher, so that once you parallel the generator, it will supply power to the system. If these frequencies are exactly same, what happens is that due to this little bit of transient, one actually drops a little bit in speed, and in fact it starts a little bit of motoring action. Okay, so the frequency should be slightly higher, not very high, very slightly. Minute difference in frequency should also be there. Another thing is that in methods like dark lamp methods or using synchroscopes, there should be a little bit of frequency difference to understand when you have to synchronize the generators. All these things will be explained very clearly when I do a lecture on the synchronizing procedure. Okay, so to understand where to synchronize, there should be a little bit of difference in frequency. Okay, very minute difference, but a little bit of difference should be there. So today I think we can conclude the generator. We have gone through some important points, that is conditions required for paralleling. So if you have liked this video, please like, share and subscribe the channel. In the next session, let us go through the synchronizing procedure, in which we will be discussing about the synchroscopes and the dark lamp methods. Okay, so till I see you in the next video, it's me Varun signing off, and have a great day. Thank you.